Let's find the ordered pair solution to this system of linear equations in two variables. We're finding that one point where the two lines would intersect. We're finding that one solution that would solve this equation and this equation. Now, in our previous example, we were fortunate in that the coefficients for the y variable were additive opposites. One was positive 3, the other one was negative 3. So we simply added the equations together, and the y variable disappeared, creating a linear equation in one variable, x, which we solved. Well, we're not as fortunate here. These numbers aren't additive opposites. One coefficient is positive, the other coefficient is negative. That's a good start, but they aren't additive opposites. Positive 2 and negative 3 aren't additive opposites. So what I want to do is I want to algebraically make them additive opposites. And the number that I want to put here is the least common multiple for 2 and 3. And the least common multiple for 2 and 3 is 6. So I want to multiply this entire equation by a quantity that will make that coefficient of y become plus 6, and multiply here by a quantity that will make this coefficient of y minus 6. And I think you can see what those multipliers would be. If I were to multiply this equation, and make sure you multiply the entire equation, both sides, every term on both sides, or you'll throw your equation out of balance and find a false solution. If I multiply this equation by 3, it's going to give me 9x plus 6y equals 48. And multiplying this equation by 2, 4x minus 6y equals negative 22. Now when I add those equations, again, because I've now created additive opposites here for the coefficient of y, those terms disappear, leaving me just 9x plus 4x is 13x. 48 minus 22 is going to give me 26. I've created a linear equation in one variable that I can finish out by dividing both sides by 13. We have x equals 2. So now we know that in the ordered pair, that is a solution to each equation, the x value of that ordered pair is 2. And now we simply take that x value of 2, put it in place of x in one of the two original equations, and solve that resulting linear equation in one variable for y. 6 plus 2y equals 16, subtracting 6 from both sides. 2y equals 10, dividing both sides by 2. So x being 2, y being 5, is the solution to that system of equations. Let's make sure that ordered pair works for both equations. If x was 2, 2 times 3 would be 6, plus 2 times 5 would be 10, 6 plus 10 indeed is 16. 2 times 2 is 4, minus 3 times 5 is 15. 4 minus 15 is negative 11. Yes, this is the solution to this system of linear equations in two variables.